some examples for you. Most of these derivative ones, they're kind of laid out because they're on page 464. And so mostly just chain rule, right? Here's chain rule. You got to let u, and then you actually have another u inside there, right? The derivative of that. The derivative of that is the derivative of the inside alone. Leave the inside alone. Derivative of the inside, which is just e to the x. And then you times by the derivative of the inside, which is just derivative 2x is 2. So then the hyperbolic tangent derivative is going to be hyperbolic secant squared of x. But my x is not just x, it is. I leave the inside alone. Then I'm going to times that by the derivative of the inside, derivative of that, which is just 2e to the 2x. So this is just 2e to the 2x times hyperbolic secant squared of 1 plus 2. 1 plus e to the 2x. All right, so chain rule. Chain rule inside a chain rule. All right, let's look at this next one. Hyperbolic cosine of ln of x. So that is chain rule again. There's my u. The derivative of that is just derivative of ln of x equals 1 over x. Derivative of hyperbolic cosine is hyperbolic sine. So I leave my inside the same. Oops. And then I multiply by the derivative of the inside. So I get this. Then I can go ahead and substitute what this is, which is e to the ln of x, which is just 1, or x, minus e to the negative ln of x, because remember, all over 2. Hyperbolic sine is e to the x minus e to the negative x all over 2. Well, that 2 I can rewrite as a half, because this is all over x. I get that x from right here. Okay, so this is x minus 1 over x times by 1/2 over x. Well, dividing by x is the same thing as multiplying by 1 over x, right? So I get 1 minus 1 over x squared times 1/2. Or you could simplify that with a common denominator. Get x squared minus 1 all over x squared. Distribute the 2. So x squared minus 1 over 2x squared. There you go. So like that. Which is ln of x over x. Those are equal. Okay, so that was a little more complicated, but it's using the definition of hyperbolic sine of something. Okay, here's another one, hyperbolic cotangent. So the derivative of hyperbolic cotangent is going to be negative hyperbolic squared of cosecant. Hyperbolic cosecant squared, that's how you say it. All right, but it's product rule, right? So I have to do the derivative f prime times g plus g prime times f, right? So here's my f. Here's my f prime. Here's my g. And the difficulty is the g prime, right? Which is chain rule. Hyperbolic cosecant squared. Leave the inside alone. Times the derivative of the inside, which is 2x. So there needs to be a 2x and negative 2x. So there you go. So it's going to be derivative first. 1 times this, which is just hyperbolic cotangent of 1 plus x squared, plus g prime, which is this, times this. So that just becomes negative 2x squared. So really I could get negative and a positive here, just negative, like that. And then cosecant, hyperbolic cosecant squared of 1 plus x squared. All right, so that's mostly the chain rule. I mean, derivatives, mostly doing chain rule and product rule maybe inside it. Now the harder ones is the integrals. So there is no real tangent. You see no answer there. You see no list of integrals for these hyperbolic sine or inverse hyperbolic functions. So you're going to have to rely on what you know about kind of basic tangent, right? You can rewrite tangent as sine. So hyperbolic sine over hyperbolic cosine of x. Okay, and then the only rule we know other than straight integrals is substitution rule. And we know the derivatives of these are going to be they're the opposite or each other, right? So the derivative of this is hyperbolic sine, right? Okay, so I'm going to let my u equal this. So then it's 1 over of u dx, and then I could rewrite that as 1 over u hyperbolic sine x dx. And now I know my du needs to equal this. So when I take the derivative of my u, which is my u's right here, so when I take the derivative of that, I get du equals hyperbolic sine of x dx, which is, that's exactly what that is. So there's my du. And now we know the integral of 1 over u is ln of u. And my u is hyperbolic cosine. And since I'm doing the indefinite integral, I just add my c at the end. All right, this one's a little more into it a little bit. But again, I'm going to let my u equal the bottom because I know the integrals of this, right? That's just ln of u. That's why I'm doing mostly the bottoms here. So I'm going to let my u be the bottom. So then I'll be left with this. So that means my bottom, when I take the derivative of my bottom, it has to equal that, which I can look. And so what I'm kind of doing is I'm looking at my top and at my bottom here, and I'm looking, okay, where do I have in my list on page 466 the inverse ones of hyperbolics, or my straightforward ones, the derivatives on 464, and I'm looking for, okay, where do I have an answer of this, of my derivatives, or where do I have an answer of this, of my derivatives? And I look at the I see that the derivative of hyperbolic tangent is secant squared. So I have a derivative that has an answer of this top one. So that's why I take the derivative of this, or that's why I take the u equal to the bottom. Because when I take the derivative of that, I get du of derivative 2 is just 0. Derivative hyperbolic tangent is the secant, hyperbolic secant squared of x, and then my dx, which is exactly what I need, right, for my du. So now I can take the derivative of that, which is ln of u, but my u is this right here, bottom. So ln of 2 plus hyperbolic tangent. And so there is my, oh, there's not an n at the end there. There's just an x. Sorry. And so there is my answer. And I mean, you could probably get more complicated. You could actually substitute what this actually is, which is on page, let's see, 462, but I'm not going to do that. So there's the end of that one right there. Okay, so this is very similar to your number 65 that you're having problems with. So I want to look at my answers for my derivatives of something looking like that. So something of 1 over a square root of, looks like something being squared plus 1. All right, so if I look at that, there's supposed to be a dt at the end of this. If I look at that list, I see my answers there are in my inverse hyperbolics. So my inverse hyperbolics on 466, I can see that inverse of hyperbolic sine, so if I take, looks like this, inverse of hyperbolic sine, the derivative of that, there's an x in there. is 1 over square root of 1 plus an x squared. So it has a 1 over the square root of something, which my answer does. And then it has a 1, which mine does. And then it has a 1, and it has an x squared. But I have a 16t squared, but it is still something being squared. So how can I rewrite this 16t squared as just something squared, right? Well, I can take that 16 and rewrite that as 4 squared, and t is being squared. So I could rewrite this as 4t is being squared. So if I do substitution rule, I could let my u just go ahead and equal the 4t, because that's what something's being squared. And then the derivative of that is just 4, right? What you're going to have to do on yours is you'll have a t squared like that, but this won't be a 1. It'll be, I think it's a 9. But either way, whatever it is, you are just going to have to rewrite it. So how do I rewrite something to turn it into 1? Don't I just divide it by itself? So for a quick example, sidetrack. So if I have, say, 12 over square root of x squared plus 16, okay? And I want this to be 1, well, I have to divide that by 16. That means I would also have to divide this by 16. But that is the same thing as x over 4 squared, right? And then my top, I would also have to divide that. But I'm not dividing by 16 because this 16 is inside this root. So really, what's outside the root is actually a 4, right? So this top one, I have to divide by 4. So that means I could rewrite this as 3 over square root of x over 4 squared plus 1. Now I can go ahead and take the integral of that. And so I probably should start with an actual 4 up here, because then that would have made it work, because then this would be 1. And now you have 1 over the square root of something squared plus 1. And so you go ahead and simplify it that way, okay? All right, let's go ahead and finish this out. So now I know what my u equals, okay? So u equals 4 for me, or 4t for me. So I'll substitute that in. So this is just going to be u squared here, because my u is 4t. That squared is 16. I get that. Like on this one, my u would be x over 4. Okay, that's what my u would be on this problem. So you can use that for 65. All right, and then I have a dt at the end. All right, so now I know exactly what that is, right? Except for I have to do my whole this thing, right? I have to take the derivative of u, what I substitute, which is, this should be a t, because I'm doing it in terms of t, which I probably should have did on the last problem. So if I divide that by 4, divide that by 4, so my dt is actually equal to du over 4, or a quarter, right? So this is now going to switch to du, and the fourth is just going to go out front. Now I can take the integral, because I know what this is now. This is inverse hyperbolic sine of u from 0 to 1, and times by 1/4. So now I can actually substitute what back in my u is, which is just 4t. Zero to 1 times 1/4. Now I can actually write what inverse hyperbolic sine is, which that list is on 465. So that is ln of my x, which is 4t, minus plus square root of my x squared, which is 4t squared, plus 1. And then I have to plug in 1 for my t, and then subtract, plug in 0. So ln of 4 plus square root of 4 squared plus 1. And then minus ln of, plug in 0, I get 0 plus square root of 0 squared is just 0 plus 1. So that's just going to be, oops, ln of 1. So that's ln of 1. And I'm subtracting 2 logs, 16, 17. So subtracting 2 logs with the same base, so they can just be over each other. It just simplifies to ln of 4 plus root 17, and the 1/4 is in front of that. So there's my answer. So you're going to have to do u, but you're going to have to look, see what it exactly kind of looks like, what kind of form kind of does that, and how can you manipulate it using u. Again, that square root thing, like I did here. All right, if I'm turning that into 1, I have to divide by 16, but that 16 is underneath the square root, so really 4 is on the outside. And then I have to manipulate this to something being squared, so that's x over 4 squared, so then for my u is x over 4. Okay, so that's kind of how you do these.